5.3 solves linear systems by elimination. So the elimination method is an algebraic method of solving a system of linear equations. A system of linear equations can be solved algebraically using the elimination method. To solve a linear system by elimination, the equations are either added or subtracted in order to eliminate a variable. So when each term in an equation is multiplied by a constant, the resulting equation produces the same line when graphed. Okay, so they're going to be equivalent. Okay, example 1. Add or subtract the following equations. So we are going to, in this case, in A, add these two equations. So if you can tell, the x's are stacked, the y's are stacked, the equal signs are stacked, and then the constants are stacked. So we can go ahead and add. What is 2x plus 4x? Well, we get 6x. Negative 3y plus 3y. Well, we get 0. Those cancel out, right? So you can either put 0y or you can just not write it. And then negative 5 plus 10, I get 5. So in other words, 6x equals 5. Okay, when we subtract equations, we need to subtract every single term, not just the first one. From like this negative sign or the minus sign being in front of this equation, it looks like it just applies to the 2x, but it actually applies to each and every term. So 2x minus 2x, those would just cancel to 0x. Negative 6y minus positive 7y, I get negative 13y. And 8 minus negative 5, I get 13. Okay, and then in C, we're going to add these. So 5x plus 3x, I get 8x. Negative 7y plus 7y, those cancel. And 2 plus negative 1, I get 1. Okay, so example 2 asks us to use the elimination method to solve the following linear systems. So it's going to be very similar to what we just did, where we add or subtract to get rid of one of the variables. So when I'm taking a look at these two equations, I notice that both of them have a 2x. So in order to get rid of this variable, we're going to subtract that second equation. So 2x minus 2x, those will cancel. Y minus negative 3y, I get 4y. And 8 minus 0, I get 8. At this point, we have one variable, and we can go ahead and solve. So divide both sides by 4, and we get y equals 2. We're going to take that 2, and just like the substitution method, we're going to sub it back into one of the originals. So let's go 2x plus y equals 8. Okay, I'm going to go 2x plus 2 equals 8. Bring over that 2, it becomes negative 2. 2x equals 6, and then divide out. So in this case, I get x equals 3. I get that the point of intersection is 3, comma 2. Even though we solved for y first, the point of intersection is in the form x comma y. Now, in order to check, we actually have to check both equations, and this is how we do it. So we write out both equations as they are, and we sub in 3 for x and 2 for y. Okay, 3 for x, 2 for y. Okay, and we get 6 plus 2 equals 8. 8 equals 8. Yes, it does. So this point of intersection satisfies the first equation. Now, 6 minus 6 equals 0. 0 equals 0. This point of intersection satisfies the second equation. Okay, B asks us to do the same thing. So taking a look at B, we have the y's have the same coefficient. They both have the coefficient of 1, except for the first equation we have 1y, and the second equation we have negative 1y. So we can still work with this to eliminate. All we'd have to do is add the equations this time instead of subtracting. So we have 3x plus 4x. I get 7x. Y plus negative y cancels. And 19 plus 2, we get 21. Okay, divide both sides by 7, we get x equals 3. So choose either of the two originals. I'll just do the first one. And we're going to sub 3 in for x. So 3 times 3 plus y equals 19. 9 plus y equals 19. And then we can bring over that 9. It becomes negative 9. So y equals 10. Our point of intersection is 3, 10. Now, in order to check this point and make sure that it satisfies both equations, we're going to write out both equations on the bottom of the page, and we're going to sub in 3, 10. So 3 plus 10 equals 19. 3 times 3 is 9 plus 10 equals 19, and we get 19 equals 19, which it does. So this point of intersection satisfies the first equation. Now, on to the second equation. Substitute in the 3 for the x and the 10 for the y. And we get 12 minus 10 equals 2. 2 equals 2. Definitely satisfies the second equation. So this is the point of intersection. Okay, example 4, solve the linear system. It gives us two equations using elimination. So this is the exact same thing. All we have to do is stack the equations ourselves. So I'm going to get a new color. Green. Okay, so 8x minus 11y equals 5. And then we have 4x plus 17y equals 25. So here's the issue. The coefficients on the x's are 4 and 8. Okay, those aren't the same. The coefficients on the y's are 11 and 17. Those aren't the same. We don't consider the coefficients on, the constants, because we want to get rid of a variable. So getting rid of a constant is not going to get rid of the x or the y. Okay, so what we have to do is we have to think, can we multiply either of these equations by a constant in order to get the same coefficient? So in my head, I'm thinking, if I multiply this second equation by 2, in this position, I'm going to get an 8x. So 2 times 4x, I get 8x. 2 times 17y, and I get 34y, and then 2 times 25, and I get 50. Okay, this time, and this one we're just going to bring over. 8x minus 11y equals 5. At this point, we have two coefficients that are the same. What we're going to do is we're going to subtract these. So 8 minus 8 cancel out. Negative 11 minus 34. We're going to get negative 45y. And 5 minus 50, again, negative 45. And divide both sides out by negative 45. We're going to get y equals 1. Okay, we're going to take this y, we're going to sub it back into either of the originals. So 8x minus 11y equals 5. 8x minus 11 equals 5. Bring over the negative 11, and we'll get positive 11. 8x equals 16, and divide out and solve. Oh, I think that's 2. Okay, so therefore the point of intersection is 2, 1. Okay, exact same thing for example 4. We're given two equations here, and it says solve the linear system using elimination. So let's go ahead and stack these on top of each other. Okay, the coefficients of the x's are 3 and 4. Those are not the same. The coefficients of the y's are 1 and -2. Those are not the same. However, this 1 here is really easy to work with because we can multiply it by whatever we need to get 2. So let's go ahead and multiply this first equation by 2. Remember, multiplying an equation by a constant doesn't change that equation. It makes it look differently, but the line is actually going to still be equivalent. It's going to be the same line. So let's distribute the 2 into the bracket. 2 times 3x is 6x. 2 times 1y is 2y. And 2 times 6 is 12. Now we're just going to bring over this second equation. And now we have a 2y and a -2y. So because these are opposite operations, we're actually going to add these equations. 6x plus 4x, I get 10x. The y's cancel. And 12 plus 8, I get 20. Okay, divide out the 10, and I get x equals 2. I'm going to sub that back into the first equation. 3, 2 plus y equals 6. 6 plus y equals 6. I'm going to bring this 6 over. It becomes -6. And I get y equals 0. So therefore, the point of intersection is 2, 0. Okay, last one, example 5. This is going to be a word problem. Mark works in a department store selling sports equipment. Okay, baseball gloves cost $29 each, so it's gloves. And bats cost $14 each. Okay, one shift he sells 28 items. His receipts total $647. So this is where we find out what we're talking about. How many gloves did Mark sell? How many bats did he sell? Okay, so we're going to go let G represent the number of gloves sold. Okay, and we're going to let B represent the number of bats sold. Okay, so we have two totals here. We have 28 items. So what that means is the number of gloves plus the number of bats equals 28. Okay, now converting this all into money, we're going to have the amount of money he earns off of gloves is going to be $29 times the number of gloves he sells. Okay, and the amount of money he's going to earn off bats is going to be $14 plus the number of bats he sells. And this is going to equal 647. So we have two equations. I'm going to focus on elimination for this. You can also do substitution, but just because we're under the elimination heading, let's do elimination. So the coefficients of the G are 1 and 29, and the coefficients of the B are 1 and 14. So neither of these have the same coefficient. That means we can pick any number to multiply this first equation by to get a duplicate of the second equation. So let's pick 29, just easily that first number. So 29 times G, 29 times B, 29 times 28. We're going to get 29G plus 29B equals 812. In this second equation, we're just going to bring over 29G plus 14B equals 647. Okay, now the coefficients of the G are the same now. So what we're going to do is we're going to subtract. So that we get 29G minus 29G, and those cancel. We get 29B minus 14B, okay, and we're left with 15B. 812 minus 647, and we get 165. Okay, divide out the 15, and we get, not y, b equals 11. Okay, so we take that b equals 11 and we sub it back into either one of the first two equations. So the first equation is a little bit easier because, I mean, we're dealing with the numbers like 1g and 1b rather than 29 and 14. Right? So g plus, substitute in that 11 equals 28. Bring that 11 over. We're going to subtract it. So g equals 17. Okay, so therefore, mark cells 11 bats and 17 gloves.